Hey guys, it's Mathematics YT. Today I am going to prove the first n term formula for arithmetic progression. So the formula for this is equal to n over 2 times 2a plus n minus 1 times d, where a is the first term of the arithmetic progression, and d is the common difference of the following arithmetic progression, and this n represents the first n term, the value of n, where n must be positive integer. And you also see this n over 2 times a plus l, and this l means the last term of the first n term of the arithmetic progression. And if you don't know what arithmetic progression is, so arithmetic progression. So arithmetic progression basically means that the sequence that involves addition and subtraction. So arithmetic progression means the sequence that involves addition and subtraction. And in this video I'm going to prove the first n term formula. And and before we start this video, make sure you guys hit the subscribe button and like the video so you won't miss any interesting math video like this. So let's get started. So let's start prove this formula now. I will simplify this term into one short operation, and I will use sigma, which means the notation of sum. So I will use sigma from n is equal to 1, no, I don't want n, let's say r to n for the sum of a plus n minus r minus 1 d, where a and d is still the same thing. And as we expand this, so we can expand this, so this thing is equal to a plus d plus a plus 2d until a plus n minus 1 d. And I am going to let L equal to a plus n minus 1 times d, where L is the last term. And it makes sense because this L represents the last term for the first n term of the arithmetic progression. And to do that, now if this is n minus 1, then the previous one is n minus 2. So the previous term for here is plus a plus n minus 2 d, a plus n minus 2, and I'm going to expand this thing out, so I will get a plus n minus 1 d plus a minus n minus 1 d minus d, because I have extract the minus 1 out. Since negative 2 is minus 1, then I express this term as one term, and I'm going to expand d to this negative 1, so I can get a plus n minus 1 times d minus d, and this thing is going to equal to L. So a plus n minus 2 times d is equal to L minus d, and as you guys can see that the pattern continues. So this thing is going equal to a is going to equal to wait. This thing is going to equal to, now from this thing is L plus this L minus d plus L minus 2d plus until until L minus n minus 1 D. And this thing is going to like yeah, the pattern is continue until n minus 1 from 2 to 1 and n is equal to, and this thing is become 0, and this is L not 1. Just to remind you guys that this thing is 1, and we can simplify it into another equation. That is equal to the sum of r is equal to 1 to n and of for the term L minus r minus 1 times d. So this is the second equation that is simplified in form of sum of notation, aka sigma, and we are going to plus that together, and I need another paper now. So we are simplified these two things. So let's summarize these two. So these two formula, they are exactly equal to the equation that is also exactly equal to this equation, and we got two of them. So what are we going to do? We are going to sum it up. Well, you see, I have plus r minus 1d and I have minus r minus 1d. So the strategy is, if I sum it up, what will happen? This and this cancel out. So let's do it. Now this Sn plus Sn is equal to this and Sn is equal to this, and when I add it up, so Sn plus Sn each is equal to, now the sum of r is equal to 1 to n of a plus n minus 1 times d. I mean r, because I used to. Now I am not going to plus this again. Instead of plus this once again, I will going to plus this, because don't forget this is exactly equal to this. So I will plus the sum of r is equal to 1 to n for L minus n minus 1 d. Now look at this. Since we have two sigma notation, and the lower limit and upper limit are exactly same, which means what? We can unify these two things. We can unify these two things. So 2Sn is equal to n of this is from r is from 1 to n from a plus n r minus 1, this is r minus 1 times d plus L minus r minus 1 times d, and these two cancel out because when we add it, it becomes 0. So the remaining term for here is 2Sn is equal to the sum of r goes from 1 to n a plus L. This is L. Don't forget, this is L. And since A and L are constant, we should just need to use this formula. Now this thing is going to be equal to, so 2Sn is equal to, now if we have a sigma from r is let's say I will use the term r goes from A to B, and I will have C here, where A, B, and C are all constant, which that thing is equal to I, capital I, C, where I represents the difference between the lower boundary of A and upper boundary of B. So which means what? This plus 0.5, and this thing also this minus 0.5. Now I get the lower boundary, and this I will plus 0.5, and I how to say it? And I add it together. So by using the same strategy right here, so this thing will equal to a plus L, this multiplied by the lower bound, multiplied by the difference between the the lower boundary of 1. The lower boundary of 1 is 0.5 and the upper boundary of n is n plus 0.5. So this thing going to multiply by n plus 0.5 minus 0.5. You are going to subtract each other because this is lower limit, this is upper limit. So you need to, so if you have a constant as expression, you are going to this constant, the expression, multiply by the lower and upper boundary between these two terms, that is the lower limit and upper limit. And these two cancel out, then 2Sn is equal to n times a plus l, n times a plus l. Then Sn is equal to n minus 2 times a plus l. And this is the equation that we come out, where l is the last term, a is the first term, and n is the sum of the value of n that states in the question, right? Like the first 89 term. So if it say first 89 term, which means n is equal to 89. And if we undo the substitution, where is it? Yeah, here. Now if we undo the substitution, now L is equal to a plus n minus 1 d. So if I substitute L to here, then I can get what? This thing is equal to n minus 2 plus times a plus n minus 1 d. This is going to n minus 2 times 2a plus n minus 1 d. And this is equal to Sn. This is also equal to this. So that's how we can get by using the formula. So we can summarize all things, so we can get these two different results, but we can get the same answer after we substitute each of these value. Now this is not only the way that proves about the first n term for the arithmetic progression. There's still another way, and I will show you the second way of proving the first n term for the arithmetic progression. And now let me show you the second way to prove. Now look at this. I have a plus d plus a plus 2d until a plus n minus 1 times d. And how many a's we can get? Now from the first term, let's say from first term to n, so how many terms that I can get from this by expressing this n terms, right? From the first term to the last term, we have n term. The last term of the first n term, that is yeah, this thing. This here is the last term for the first n, for the sum of first n term for the arithmetic progression. And from a to a plus n minus 1d, we have a total of n term. Now we have a, and we have also a in this dot. Now if we have a that has n a's and a's, which means that we are going to sum for n times. So if we like separate the expression, because we just plus them together, so we don't need the bracket. So I get a plus dot plus a plus a. This thing is going for n times. So if this thing is going for n times, what we can get? An, right? A times n plus. Now this here I don't have d, but I have d here. I have d here. I have d d. And this is 1d plus 2d plus 3d plus until n minus 1. We can some sort simplifying this like by using the sum of notation. So this I have d plus 2d plus 3d plus until n minus 1d. Until n minus 1d. And this is going to be equal to the sum of r is equal to 1 until n minus 1 r d. And when r is equal to 1, I substitute here d, r is equal to 2d 3d until n minus 1. So we can simplify become this, and this is going to equal to r is equal to 1. R goes from 1 to n for the expression r times d, where d is a constant. Now d is a constant, so I will separate this just not to confuse you guys. Look at this. This is just like the same situation as we face when we are going to find a value for the r that is in the power of 1. Now remember this formula. When we have, let's say I goes from 1 to n, for I with the power of 1, this is going to be equal to n times n plus 1 over 2. We are going to use that same concept for this term, and the sum of r goes from 1 to n minus 1 of r. So by using this same strategy, we are going to plug in the n minus 1 to here. So this thing is going to be equal to an plus, and this substitute to there, I get n minus 1 times n minus 1 plus 1, that's n over 2 times d. And we can factorize n minus 2 out. So this thing is equal to n over 2 times n over 2 times 2a plus n minus 1 d. And you are done, fast and quick, right? And this, since we are factorizing the 2 out, and we have n, so we can factorize n out. And I think 2 is annoying, so I'm going to factorize 2 out. But to factorize 2 out, we don't have 2 here, but we are going to factorize 1 over 2, and at the same time I'm going to multiply by 2, so that the whole thing is still exactly same, has the same value. So this method is like pretty fast. This method is pretty fast to prove. Now just now we have proved, just now this thing is equal to the sum of r goes from 1 to n for a plus n minus 1 d. This is the formula for that. And don't forget the last term, L is equal to a plus a minus 1 times d. So L is equal to a plus n minus 1 times d, and plug in that, we can get a plus l. So so this is going to be equal to n over 2 times a plus l. And just now we have figured about this thing is going to be equal to the sum of r is equal to 1 to n of l minus r minus 1 times d. And this is not, and I just used to write n instead of r, because this is the formula that we always remember when we are talking about arithmetic progression. And this, look at this equation. If I use the same concept to make this right, if I use the same concept as we get like right here, then we can get what? Just figure it out. We can get n over 2 times l minus 2l minus n minus 1 times d. We are just repeating the same process, but in terms of l. So when you have when the teacher asks you about the last term, but the question didn't mention about the first term, then but you are worrying about the formula, like you ask this you ask teacher, right? Hey, but don't worry, if the question did give the last term, you just use this formula to solve. And basically you are just going to use the same exact same method from this and this I come up with myself. And the method just now come out from the book. And this is, yeah, we still can get the exact same result. And the difference between this thing is we have in terms of first term and we have in terms of last term, and this is neutral, because if I plug in L right here, so A is equal to L minus A n minus 1 times D. I can straight away plug in the A right here because I have the extra L plus L minus n minus 1 times D, so become L plus A. L plus A is same as A plus L, so which means that this is like neutral. And this term is in terms of positive, like the first term, and this is like the last term, and this is neutral. And so we have not 2 but 3 equations. So that is like pretty amazing. And if you guys like this video, leave a like and subscribe to the channel, and I will see you guys next time in another video.